Good morning. I am Reggie, Associate Professor, Department of ECE. Today in this session we are going to discuss about noise characterization of microwave receiver. Once we completed the topic, students will know what is a noise, what are the classifications of noise. Noise characterization of microwave receiver. Noise is defined as an unwanted form of energy which tend to interface with the proper reception and the reproduction of transmitted signal. Electronic devices unwanted random addition to signal are considered as noise. Classifications of noise. There are several ways to classify noise, but conveniently noise are classified into internal noise and external noise. Classifications of noise. External noise. External noise is defined as the type of noise which is generally externally due to communication system. External noise are analyzed quantitatively. Now external noise may be classified as atmospheric noise. Atmospheric noise is also known as static noise, which is the natural source of disturbances caused by lightning discharge in thunderstorm and the natural disturbances occurring in nature. Industrial noise. Source of industrial noise are automobile phone, aircraft, ignition of electrical motor and switching gear. The main cause of industrial noise is high voltage wire. This noise is generally produced by discharge present in the operation. Terrestrial noise. Terrestrial noise exists on the basis of originating source. They are subdivided into solar noise, cosmetic noise. Internal noise are the types of noise which are generally internally or within the communication system or in the receiver. They may be treated quantitatively and also reduced, minimized by the proper designing of the system. Internal noise are classified into short noise. These noise are generally arise in the active devices due to random behavior of charged particle of carrier. In case of electron tube, short noise is produced due to random emission of electron from cathode. Classification of noise. Short noise. These noise are generally arises in the active devices due to random behavior of charged particle. In case of electron tube, short noise is produced due to random emission of electron from cathode. Classifications of noise, the other apart from that one is partition noise. When a circuit is to divide a two or more path, then the noise is generated is called as partition noise. The reason for the generation is random fluctuations in the division. There are low frequency noise or otherwise called as flicker noise. These types of noise are generally absorbed at the frequency range below few kilohertz. Power spectral density of this noise increases with the decrease in frequency. That is why it is called as low frequency noise. Low frequency noise, flicker noise, frequency noise, high frequency noise. These noise are called transit time noise. They are absorbed in the semiconductor devices in the transit time of charge carrier while crossing a junction compared to time period. Thermal noise. Thermal noise are random and often referred as white noise or Johnson noise. Thermal noise are generally absorbed in the resistor of a sensitive resistive component of the complex impedance due to random and rapid movement of molecules. Microwave noise in microwave circuit. Noise power is the result of random process such as flow of charge or holes in the electron tube or solid state devices propagating through the ionosphere or other ionized gas, or most basic of all, the thermal vibration in any component as the temperature above the absolute zero. Noise can be passed in the microwave system from external source or generated with the system itself. In case of noise level or system set the lower limit on the field distance, then they detected in the presence of noise. Thus, in general, it is decided to minimize the residual noise level of a radar or communication receiver to achieve the best performance. In some cases, such a radiometer or noise astronomy, the desired signal is actually the noise power received by the antenna, and it is necessary to distinguish between the received noise power and undeceived noise. Signal to noise ratio. Noise is usually expressed as the power between the received signal is also in terms of power. By knowing the signal to noise ratio, power the signal to noise ratio can be computed. Rather than express the signal to noise as simply a number, you will easily express as signal to noise ratio is 10 log signal power divided by noise power, is 10 log ps by pn. A receiver has the input signal power at 1 mega. The noise power is 0.8. The signal to noise ratio is 10 log 1.8 by 1.0. Noise figure. Noise figure is designed as the ratio of signal to noise ratio at the input to the signal to noise ratio at the output. The device under consideration can be entire receiver or a single amplifier change. The noise figure also called as noise factor, which is combined by the expression F is equal to signal to noise ratio input by signal to noise ratio output. You can express the same noise figure as number and often expressed in decibel. Thank you.